In this lesson, we are going to talk about the basic information you need for this unit. The first one is the square of any number. We define the square of any number to be the number times itself. So if you take any number and you multiply it by itself, you're finding the square of that number. Now, the only thing you have to remember, the square of a negative number is always positive. The reason is that if I have, let's say, negative 3 squared, by definition this is negative 3 times negative 3, but negative times negative gives you positive, and 3 times 3 gives you 9, which is a positive number. Let's do a couple of examples here. First one, what is square of 3? The square of 3 by definition is 3 times 3, which is going to give you 9. The next example, what is square of 2? Square of 2 by definition is 2 times 2, which is going to be 4. What is square of negative 4? By definition, this is negative 4 times negative 4, which is going to be negative times negative gives you positive, and then 4 times 4 is 16. So the answer is 16. The next example is negative 5 squared. So negative is negative, and then 5 squared is 5 times 5. So the answer is negative 25. Now, if you remember when you were solving linear equations, you were solving it by moving the items around to the right or left, and whenever you're doing that, you're really doing the opposite operation. And remember, the opposite operation for addition is subtraction, for subtraction is addition, for multiplication is division, for division is multiplication. Now the question is that what is the opposite operation or the inverse operation for square of a number? Now, the opposite operation of squaring is what we call square root, which we define it with this symbol. And what it does, it will find a number that if it multiplied by itself, it gives you the square. For instance, square root of 4 is going to be 2, because if you multiply 2 by itself, you get 4, or the square of 2 is equal to 4. Now, one thing that you have to remember is that the square root of a negative number does not exist. This is very important. This means that the square root of negative 4 does not exist. So this is invalid. There is no such a number that if you multiply by itself, it gives you negative 4. The next question asks us to find the square root of 36. Remember, the square root of any number is to find another number that if you multiply by itself, it gives you 36. We know that 36 can be written as 6 times 6. So this square root of 36 is really number 6, because if you multiply 6 by itself, you get 36. The next example is square root of 100. We know that 100 can be written as 10 times 10. So square root of 100 is really 10. Again, because 10 times 10 gives you 100. So square root of 100 is 10. The next one is negative square root of 121. We know that square root of 121 can be written as 11 times 11. So the answer is negative 11, because if you multiply 11 by 11, you get 121, and there is a negative outside the square root, so you get negative 11. The next example is square root of negative 25. We said that the square root of any negative number is undefined, so we say this one, there is no answer for this guy. This is not defined. The next topic that you should know for this unit is solving linear equations. First of all, what is exactly a linear equation? As we said before, the degree of equation has to be 1, meaning if you have let's say 2 variables in your equation, then the maximum exponent of the variables is 1. For instance, y is equal to 2x minus 1. The exponent of y is 1, although it doesn't show it. The exponent of x is also 1. The maximum exponent is 1, so this is a linear equation. But if you have an equation like x cubed minus 2x, since the maximum exponent here is 3, this is not a linear equation. In fact, this is a cubic equation, which we do not consider here. But for a linear equation, meaning degree 1, remember from grade 9, the way that we find the solution is by doing the opposite operations. Now, the opposite operation was to isolate the variable, let's say x, on one side of equal sign, either left or right, and then all the numbers on the other side. The only thing that you have to consider when solving linear equation is that whenever you move an item to the other side of the equal sign, you have to change a sign. And when you solve the linear equation, the last step is always checking your answer. And this check was the LHS, RHS method, left hand side, right hand side method. So we are going to now do a couple of examples just to see how the system works. The first example is to solve and check 2x plus 1 is equal to 7. Again, I decide where I want to keep the variable. The variable is on the left, so I'm going to keep it on the left. This means that number 1, which is here, I have to move it to the right. So I get 2x is equal to 7. When you move plus 1 to the right, it becomes negative. So I get 2x is equal to 6. Now, the problem that I have is 2. To get rid of 2, I'm going to divide by 2, the opposite operation. 2 cancels with 2, so I get x is equal to 3. Now, the last step is to check to see if 3 is really the answer. So I'm going to draw a table like this, and I'm going to write the left hand side of the equal sign on the left column. So 2x plus 1 on the left and 7 on the right. Now I'm going to substitute this value, which is x equal to 3, into the left and the right hand side. So the left becomes 2 times 3 plus 1. 2 times 3 gives me 6 plus 1 is 7. The right hand side doesn't have a variable, so it's going to stay as 7. And you can see that 7 is equal to 7, so you say your solution is correct. The next example, we have 4 minus 2x is equal to 3x plus 7. Again, we decide where we want to keep variable. Let's say this time I want to keep the variable on the right and the numbers on the left. So this means I'm not going to move 4, but since variable has to be on the right, I decided, so I'm going to move negative 2x to the right. Now, 3x is already on the right, so I'm not going to move it, but 7, I'm going to move it to the left. So I'm going to have 4. When 7 moves to the left, it becomes negative 7. 3x is still on the right, so 3x, but negative 2x, when it moves to the right, it becomes plus 2x. Now 4 minus 7 gives me minus 3, and 3x plus 2x gives me 5x. Now I divide by 5 both sides, and I get x is equal to negative 3 over 5. Now again I'm going to go ahead and check. So I'm going to draw my table. The left one is 4 minus 2x. The right one is 3x plus 7. Now I'm going to substitute negative 3 over 5 into the left one. So I get negative 4 minus 2 times negative 3 over 5. Now 4 minus 2 times minus 3 over 5 is going to give me plus 6 over 5. Remember that negative 2 can be written as negative 2 over 1, and then when you multiply fractions, you multiply the numerators, then divide by the product of the denominators. Now, to add 4 plus 6 over 5, I have to have a common denominator. 4, the denominator is 1, so I multiply 4 by 5, so 5 times this guy, and then divide by 5. Now, 5 times 4 is 20 over 5, plus 6 over 5 gives me 26 over 5. Now the right one, I do the same thing. I put negative 3 over 5 for x, plus 7. Again, the denominator as 3 is 1, so 3 times negative 3 is negative 9 over 5 plus 7. But again, 7 has a denominator 1, so I multiply this guy by 5, divide by 5. I get negative 9 over 5 plus 7 times 5 is 35 over 5. Now 35 minus 9 is going to give me 26 over 5. You can see that both are equal, so the solution is correct. Now we are going to talk a little bit about the exponent rules that you learned in grade 9. First of all, remember that any number exponent n is a natural number, a positive natural number at the moment, is the product of the number a n times. So if you have a exponent n is the same as a times a times a times a, how many times? N times. The other rule that you learned before was any number exponent 0 is 1, as long as the number is not 0. So 1 exponent 0 is 1, 10 exponent 0 is 1, negative 50 exponent 0 is 1, and 1 million exponent 0 is also 1. The other thing that you learned is any number exponent negative number is the same number in fraction form with the denominator is the same power but exponent is positive. Give you example, for instance, 3 exponent negative 2 is the same as 1 over 3 exponent 2, which is 1 over 3 exponent 2 is 9. 7 exponent negative 5 is 1 over 7 exponent 5. So this rule is very important. And remember, again, any number exponent negative number is the same number in fraction form with the power in the denominator with the positive exponent. Let's do a couple of examples. For instance, we have to find 3 exponent 4. 3 exponent 4 can be written as 3 times 3 times 3 times 3. You see there are 4 3's here. Now 3 times 3 is going to give me 9. 3 times 3 gives me 9. Now 9 times 9 gives me 81. The next example is 2 exponent negative 5. Remember that any number exponent negative is the same number in fraction form with the positive exponent, but the number goes in the denominator. So this is the same as 1 over 2 exponent 5. This can be written 2 times 2 times 2 times 2 times 2, 5 times. Now, if you have a calculator, you can find what is 2 times 2 times 2 times 2 times 2, or you can do it individually. For instance, 2 times 2 times 2 is going to give you 8, 2 times 2 is going to give you 4, 8 times 4 is 32, so 1 over 32. The next example is negative 999 exponent 0. We know that any number exponent 0 is 1, so this is automatically equal to 1. The next example is a fraction exponent negative 3. Now, if you remember, we said that when you have a number exponent negative, you write it as a fraction. And the denominator, you will have the same power, but with positive exponent. So I can write this guy as this. Now, how you simplify it? You just write this one, 4 over 3 times 4 over 3 times 4 over 3. Now, when you multiply fractions, you just multiply the numerator divided by the product of the denominator. Now, 4 times 4 times 4 is 64. 3 times 3 times 3 is 27. Now, how do you divide a number by a fraction? It's very simple. The numerator, I just write it, number 1, I write it as 1 over 1. And then the division, I write it like this. And then 64 over 27. If you remember dividing fractions, you will change division to multiplication, and then you flip the fraction. So you write this one as 1 over 1 times 27 over 64. And this is simply 27 over 64. The next example is negative 0.3 exponent 4. If the question was evaluate this one without using calculator, how are you going to multiply negative 0.3 4 times? Instead of doing that, I'm going to write negative 0.3 as negative 3 over 10 exponent 4. Now, by definition, this is negative 3 over 10 times negative 3 over 10 times negative 3 over 10 times negative 3 over 10. Now, negative times negative gives you positive, times negative gives you negative, times negative gives you positive. So the answer is positive. Now, 3 times 3 is 9, times 3 is 27, times 3 is 81. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. So the answer is 0.0081 without using calculator. If you use a calculator, you will get the same answer.